Hi everyone, so here we are going to start with next session of numerical solutions for class 9 physics for St. Thomas School, Ranchi. We were seeing chapter number 1, measurement and experiment, and under this chapter we are going to start with today measurement of time and simple pendulum exercise 1C numericals. So here we are going to see the numericals related to simple pendulum. So you can see with the help of diagram when the pendulum is at its mean position, then when it goes to its extreme position, then it will start oscillating from its extreme position to mean position, and again from mean position to extreme position. So with the help of this we are going to calculate frequency and time period of simple pendulum with the help of formulas. So here we are going to see the first numerical. So first numerical is here. A simple pendulum completes 40 oscillation in 1 minute. Then we have to find its frequency and time period. So to find the frequency, what we are going to do, as in a question it is given simple pendulum completes 40 oscillation in 1 minute. So to find the frequency we have to find the number of oscillation in 1 second. So to find the oscillation in 1 second we have divided 40 by 60 and we have got 0.67 oscillation. Now with the help of formula of time period is equal to 1 by f. So 1 by 0.67 we have got the time period of 1.5 seconds. So means that with the help of formula t is equal to 1 by f or f is equal to 1 by t, we can able to find out time period or frequency of simple pendulum. Then the next numerical. In the next numerical, the time period of simple pendulum is 2 seconds. What is its frequency? So time period is given and we have to find out its frequency. So again to find out the frequency we are going to use the formula f is equal to 1 by t. So here as in the question time period is given as 2 seconds, so we have substituted 2 here and we got the frequency as 0.5 per second as unit of time. So unit of frequency is also hertz, so we can also write 0.5 hertz Hz. So next numerical here we have a second pendulum is taken to a place where acceleration due to gravity falls to 1 by 4th. How is the time period of simple pendulum is going to affect? So this question says here that there is a second pendulum. So we know what is second pendulum. Second pendulum means it is a kind of simple pendulum which takes 2 seconds to complete one oscillation. When such kind of pendulum is taken to some place where the gravity falls to 1 by 4th, then we have to find the new time period of this same pendulum. So here we have the solution. So for a second pendulum, as we know, its time period is 2 seconds, and here we are going to use the formula of time period t is equal to 2 by root under L by G. So when we are going to do the square on both the side, we will get the expression as t square is equal to 4 pi square L by G. L means here length of simple pendulum and G is acceleration due to gravity. Now we are going to substitute the value of t, which is given as t second for the second pendulum. So it will become t square is equal to 4 pi square L by G. And then further, after finding the square of this 2, that is 4 is equal to 4 pi square L by G. So this is the first equation. Now as per the question, what it is given in the question, that gravity falls to 1 by 4th second. 1 by 4th. So now when the gravity falls to 1 by 4 times, then what is going to happen? In a case of g, we are going to substitute g by 4, and then by using the formula we got t square is equal to 6 pi square L by g, and this will be equation number 2. And then next, so when we are going to divide equation 1 by 2, we got the solution as 4 divided by t1 square, which is equal to two equations which we got earlier as 4 pi L by g divided by 16 pi square L by g. And after cancelling each other, we are going to get 4 by t1 square is equal to 4 by 16, and we will get the solution further. After solving it, the time period is equal to 4, means 4 seconds. So means that when the so this means that when the gravity falls to 1 by 4th, then we get the new time period as 4 seconds. So earlier for the second pendulum, normally it is 2 seconds, but when the gravity falls to 1 by 4th, we got the new time period as 4 seconds. Means that time period increases. So next numerical. So in the next numerical, we are going to see that find the length of second pendulum at a place where g is equal to 10 meter per second square. So again, this question is related to second pendulum. So we know that time period of second pendulum is 2 seconds. So therefore, again we are going to use the formula to find out the length of the second pendulum with the help of this formula. T square is equal to 4 pi square L by g, where L is the length of simple pendulum, g is acceleration due to gravity of that place. So in a question, what are the content given? T we are going to take as 2 seconds, L we have to find, and G according to question it is given as 10 meter per second square. So after substituting these all values, 2 square is equal to 4 into 22 by 7 for the 2 times. Then L we have to find, and G is taken as 10 meter per second square. So after solving, we have got the length of the pendulum of a place whose acceleration due to gravity of that place is 10 meter per second square as 1.0142 meter. Then the next numerical we are going to see now. So compare the time period of two pendulums of length 1 meter and 9 meter. So again we have to find out the time period of two different pendulums, or we have to compare the time period of two pendulums whose length is 1 meter and 9 meter. So again, to do this, we are going to use the formula T square is equal to 4 pi square L by g. So with this formula, we have understand now that length of a simple pendulum is directly proportional to square of time period. And now we are going to find the solution now. So we are going to take the equation as, suppose T1 is the one pendulum and T2 is the second pendulum. So as T square is directly proportional to L, so therefore we have taken here t square t1 square divided by t2 square is equal to 1 by 9, as it is given that we have to compare the length of two pendulum 1 meter and 9 meter. So this is how we are going to compare, and after solving it we are going to get the ratio as 1 is to 3. So means that when the effective length of two pendulum is 1 meter and 9 meter, we are going to get the effective time period as 1 is to 3. Then the next numerical we are going to see here. A pendulum completes two oscillations in 5 seconds. Then what is its time period? If G is equal to 9.8 meter per second, then we have to find the effective length. Means that if a G of that place is 9.8 meter per second square, then we have to find out the length of that simple pendulum. And what the condition is given, that pendulum is going to complete two oscillations in 5 seconds. Then what is its time period? Means the time period we have to find, and length of simple pendulum also we have to find. So here we have this solution. So in 5 seconds a pendulum completes two oscillations. So therefore to do one oscillation, pendulum will take 5 by 2 seconds is equal to 2.5 seconds. So this means that time period is equal to 2.5 seconds. So means that in this condition we have found out how much time is taken by the pendulum to complete one oscillation. That is called as its time period. Then as we got the time period, we are going to find out the length of pendulum by using the formula t square is equal to 4 pi square L by J. By substituting all these values, we got the length as 1.55 meter. So this is how we are going to find out the new length of that simple pendulum if the acceleration due to gravity of that place is 9.8 meter per second square. So this is all about the simple pendulum. Thank you.